My name is Valeria Costa, and I will be explaining question number 56 on page 526 from Chapter 11, Solids, Liquids, and Intermolecular Forces. The question is asking us why the heat of vaporization of water is greater at room temperature than at its boiling point. First of all, let's define what heat of vaporization is. Heat of vaporization is the amount of energy needed to convert a given amount of liquid at its boiling point into a vapor state. So the heat of vaporization of water is 40.7 kilojoules per mole. In other words, it takes 40.7 kilojoules to convert 1 mole of water from a liquid to a gas. Let's look at the heating curve to help us answer our question. The question is asking us to explain why heat of vaporization of water at room temperature is greater than water at its boiling point. At room temperature, water is approximately 21 degrees Celsius. If you look at the heating curve, this puts water in the liquid phase, represented by a point along C. At room temperature, water molecules in the bulk liquid are surrounded by other water molecules. Therefore, the molecules cannot evaporate easily, and it takes more energy to convert the water into a gas. The hydrogen bonds are stronger than when water is at its boiling point. It takes more energy to vaporize water at room temperature because the water molecules need to be heated and the hydrogen bonds need to be broken in order to convert water from a liquid to a gas. When water is at its boiling point, it is at 100 degrees Celsius. On the heating curve, this is represented by D. At this point, water is vaporizing and there is a phase change from liquid to gas. The temperature of water is greater, thus more molecules can break free from the bulk liquid and can escape into the gas phase. When heat is raised and water is boiled, the water molecules have more kinetic energy, which causes hydrogen bonds to break and allow water molecules to break into the gas phase. So the heat of vaporization at boiling point is lower because it takes less energy to convert the liquid into a gas. If you think about it in steps, it takes one more step than water at its boiling point for water at room temperature to vaporize. In terms of the heating curve, water needs to go through both C and D to vaporize, but water at its boiling point only needs to go through D. At C, the temperature of water is rising to reach the boiling point, but at D, water is already at its boiling point. In conclusion, water at room temperature has less thermal energy than water at its boiling point. Remember, the heat of vaporization is the amount of energy required to overcome the intermolecular forces. Since the lower temperature of water has less thermal energy, you would have to add more energy to make up the difference. At boiling point, water is at a higher temperature, therefore it is closer in energy to the point where it can overcome the intermolecular forces, so the heat of vaporization is smaller.